Hello everyone, so today we are going to do Leetcode daily challenge, word subsets. So basically in this question, let me show you the question. So in this question, you are given, as per the question says, you are given two string arrays, word 1 and word 2. A string B is a subset of a string A if every letter in B occurs in A including multiplicity. So what does it mean? That for example WRR is there, it is a subset of warrior but is not a subset of world, because here in the world we are having R for single time but not for the two times the way it occurs in WRR. So that's why I'd want to say that including its multiplicity. And a string A from word 1 is universal if for every string B in word 2, B is a subset of A. So the thing which I want to say is that we are required to return all the universal strings in word 1, that is, it should include all the letters which would be present in word 2. That is the way here we were having this WRR. So in this warrior, we were having W and RR was twice. So that already fulfilled the requirement. But in this world, we were having W and R was also there, but R was not occurring two times. So that's why world is not a universal string. So this is the thing which the question wants to say to us. So regarding this, we are required to return all those strings with a universal string. Now let us see the constraints, how the constraints are. So words.length and words2.length. So basically the words which would be present in both of the arrays would be up till 10 raised to power 4 and minimum there would be one word. And the each word which is being present inside the words 1 array and words 2 array, that would be of length 10. So that's the thing here. So according to this, we are required to come up with a solution which do not exceed the limits of 10 raised to power 4 and 10. Basically, even if we multiply both of them, means considering the length of each word and the number of words, even if we come up with a solution, so it should lie in the range of both of these, means it should lie in the range of n into L, means shouldn't exceed either it shouldn't exceed the n square, but again we are required to search for each letter, right? So surely length would be being considered in this scenario also. So that's why we are required to come up with a solution which would be in consideration with n into L. So now, and all the strings of words 1 are unique. So there won't be any duplicate. So for that purpose, we don't need to keep a check for the same. So in that manner, we are required to go ahead. And one more thing is mentioned, that words 1 of I and words 2 of I consist of only lowercase English alphabets. So there is no comparison about the uppercase also. That is also one of the constraints which is being given to us. So that makes our question much more easier. Now, before coding this question, let me show you that how we can go ahead with the approach. Now, as per the question, it is mentioned that it should be a universal string, right? And we are given with the pattern and the words which are being there, right? So in all that scenario, like we are having this word apple, and then we would be having the word Google, right? And then we are having a pattern something like this, A, then Z. If Z is there, then it won't fulfill our requirement, means both of these would disqualify for being the universal. So if A is there and then P is there, then again P is there, then only the apple would satisfy to be a universal string, if that is the scenario. Now let us see that if this is not the pattern, if the pattern is something like this, L is there and E is there, right? And yeah, if these are the things, then in both of them L and E is there, right? And the number is also 1 1 only, right? So that's why we are required to check in that concern that its number is also 1, not only 1 but the count which is being there in the pattern, that also we need to keep in consideration, and also the count of that particular char in that word, that also we need to keep in consideration. Then only we will qualify that particular word as universal string. So in that manner we are required to go ahead. So as I told you that it is about counts, keeping the track of each letter, so we could either use a map for the same, or we could use a vector for the same, as it just need that now we as we just need the count of each letter, right? So after keeping all the letters with their count in a particular map or vector, I'm saying about these, means the pattern which is being given to us. It is somehow similar to yesterday's question, but the thing here is that we need to keep the count. And here we are not mapping to a particular word, here we are mapping according to the character itself being present in that word. Now we have count of chars, right, which we need to check in each word. That is the thing which now we would be doing after doing this particular step. So if a word qualifies consisting of all chars being stored in that, then it is a universal word. So this is a thing which we need to consider. So somehow now partially you would have got that how we are required to code this question. The thing is that first, because to consider that it is a universal string, right? So we are required to keep the count of each character which is occurring in the pattern first, right? And then from that particular map or vector, we would be checking that in the present string from the words 1 array, are we having that particular word which do have the similar number of count the way we are having in our map or vector. So what I want to say is, like, we need to check that the map which we are having, the count of the characters which we are having, do it map to these words, means exactly to these words. If yes, then it is a universal string. If not, then it is not. So like this we are required to code our solution. So let me walk you through the code, that how we would be coding this solution. So here's the code. Where's my cursor? 1 minute. I'm unable to find my cursor actually. That's not good. 1 minute. Okay, so I just lost my cursor. Okay, yeah. So in this question, now we are having this particular question. So the code which is here, now I'll walk you through this code. Please be able to find my cursor where it is. Okay, so basically in this code, how we are doing all things are, see, our main function is this, right? So what we are doing is, we are first storing a vector of where maximum frequency would be stored, and our maximum frequency would be up to 26 because there are 26 characters, and in each word there would be lowercase letters only, right? So those are 26. So that's why we are taking a constant order of one space here for this particular thing, and then vector of string of answer, which would be basically that would be the answer which we are returning. Now first thing which we would be doing, first we'll check the word in this particular, just for storing all the pattern which we are having. Then we'll check for the frequency of each word, and how we are checking for the frequency from this function we are checking. We could have checked here also, but better to maintain a modularity, so that's why we will check it separately. Again, taking a frequency vector, and then we'll first check each word in this, and then directly update the frequency of each letter, and then return the frequency. That's the thing which we are doing. And then what we are doing is that we'll check that the frequency what is there at that particular moment, and which of them is greater. So whosoever would be greater, so we'll update with the same. So this is the thing which we would be doing, because see, if we are given with this E, or F, right? So first E would have been encountered. So while doing this I until going 26, so earlier also this E would have been calculated because of this, right? So when it reaches at this moment, so here the count would be 1, but earlier it was 2, right? So this 2 would be updated at that moment. So that's the thing, we are required to do this particular step. And then what we are doing is, then we are heading towards our final step. Our final step is that here what we are doing is that again updating this particular frequency vector. It will be acting as a temporary vector for us. So here so it will be active, and then we will directly give that particular word, and it will count out all the frequencies. And then what we are doing is, we are directly traversing over that particular word which we have chosen from the words array, and then in that word we would be checking that if the frequency of that particular character is lower than the maximum frequency, then surely that doesn't qualify for being the universal set, the way it was here in the example for this particular WRR, that word qualifies for being universal set, but word doesn't. So that's the scenario which is here. Now next is that if I equals to 26, then answer dot push back word. So at the last, if I directly reaches to this 26, then we'll directly push the word which is being there. So now at the end we would be returning our answer for this particular which we have stored earlier. And this is how this particular question needs to be done. So time complexity here basically is n into L. N basically refers to the number of words which are being there in word 1 array, and L refers to the maximum length of the word which would be there. And the space complexity. So the space complexity is basically the we could consider this order of 1 also, or we could consider it as n into L itself. For that particular scenario, if we consider the answer vector which is there to be included in the space complexity, then we are required to include this particular as the space complexity also. So this is the thing, and this was the same for the yesterday's question also. So this was all for this particular question. If you have any doubt, you could comment that down, and do like and subscribe to my channel. Thank you.